Hello everyone. So we've been given this question on this stuff on external memory, right? Consider a single plate disk with the following parameters. So we have that rotational delay and all this stuff here. So the first part is what is the average seek time? Right? What is the average seek time? So average seek time in the question we've been told to assign at track number 0, and then we have 30,000 tracks. So basically we have track 0 all the way up to 29999. Yeah, because this is like 30,000 tracks in total. Okay, so how do we get that seek time? We're already at 0, right? So it will take us 0 milliseconds to go to traverse this one. But then to traverse up to the last track, we're going to divide this by 100. Why do we divide that by 100? Because every 100 tracks it takes us 1 milliseconds to traverse every 100 tracks. So I mean, to get to the last one here, we need to divide this by that 100 there, right? So what we're gonna do is we're gonna say time is going to equal 0 plus 299. If we divide that by 100, it's going to give us 0.99. Divide that by 2, which gives us 149.99 milliseconds. So the time is going to take us. This is our average seek delay, right? Next, we have our rotational delay. Now, our rotational delay, first of all, is that we're going to need to convert our 720 RPM to rotations per second. This is easily done by saying 7200. This is in R over M. You're going to then just divide this by 1 minute over 60 seconds. This is then going to give us 120 RPS, rotations per second, right? And these rotations per second, we know that 120 rotations gives us 1 second. How much does one rotation give us? It gives us x. And if we calculate this using that ratio and proportion, we say that x is equal to 1 over 120 seconds, right? 1 over 120 seconds. Now, this average, right? The average here, this average is then equal to 0 plus 1 over 120, right? Then we're going to divide this by 2, which gives us since it's going to be in seconds, I'm then just going to multiply this by 1000, give us milliseconds, about 1000 milliseconds per second, right? This is then just going to give us 4.16 milliseconds if we then do that calculation over there. Okay, sorry for that. So the next part is right. Next part we're going to then calculate here is our transfer rate, right? Part of the question says what is the transfer rate for a sector. Transfer rate for a sector, first of all, it's equal to number of bits, right, over our rotational in our rotation in RPS times the number of bits we're transferring there, right? This is then going to equal to B over, we're rotating at 120 RPS, then we'll open those brackets, and then what we're going to have here is we've been taught to say we have 600 sectors per track. Now, since we haven't been given the number of the size of each sector, what we're going to do is that we're going to say 600 times B, because this B is the size of a sector. So I mean this B and this B will cancel out each other, and then we're going to be left with 1 over 120 times 600. Plunging this into my calculator, I'm going to get 1 divided by 120 times 600, which gives me a very small number. But then that small number, this is going to give us 1.388 times 10 to the power negative 5. But then if you multiply this by 1000 to convert it to milliseconds, we get 0.013. This is in seconds. This we're going to have 8 milliseconds like that, right? we're going to have that value over there. Okay, so we've calculated this value, and then now we're going to have what is the average time to satisfy a request. This request is if, say, we're getting some random bit, right? We're getting some random value from memory. What is the average time it will take us to satisfy that request? So let's even do any of this. So the average time now, this again is going to be rather straightforward. So a total time taken, this is going to be the sum of all our times. So our average rotational delay was 19.99 plus the other time there was 1.68, right? Plus a time just from finding, which is 0.0138, which then gives us 14149.99 plus 4.168 plus 0.0138, which gives us, in two decimal places, we're going to have 154.18, right? Something like that there, right? This is the value we're going to come up with. So this is the total time taken to satisfy a request. So for most questions on external memory, it's like the general way in which you can go about solving these types of questions, right? It's the general way you can go about solving these types of questions. Yeah, if that would be all, yeah, peace.